Good morning everybody. Today I will start the topic turbine basics. So basics of turbine, what is the turbine, what are the different reaction turbine, impulse turbine, how does it work, the simple calculation I will try to discuss in this lecture. So first I will start with the definition of pump and turbine, because already I have defined pump in another lecture. So I will differentiate pump and turbine here. So pump, actually when you are talking about pump, is taking energy and giving that energy to fluid. So delivering fluid, taking energy, may be mechanical or electrical, let's say electrical. Let's say you have one electrical motor that will be delivering torque to pump, and pump will be taking energy and giving uh, to fluid. But in turbine, fluid giving energy to machine. So fluid to machine to then machine will be converting to electricity. Okay, so one example is that, like wind turbine. All right, you have seen wind turbine will be taking energy from wind, and then it will convert to mechanical energy. Mechanical energy will be going to generator. Generator will be producing electricity. But in pump, like human heart, I already told that there you are giving some mechanical energy or electrical energy, and you are delivering fluid, so that energy is transferred to fluid. Okay, so this difference you must know. So in that definition, your propeller also a pump actually. Okay, and in turbine, wind turbine, tidal turbine, wave energy harvesting turbine, steam turbine. So there are different types of hydro turbine. Hydro means hydraulic dam will be there. National Thermal Power Corporation, National Hydropower Corporation, they will have turbine also, because Thermal Power Corporation, they will be having steam will be running turbine. In Hydro Power Corporation, they will have high head from coming from river water, so that water will be delivering driving a turbine, so that is called hydraulic turbine. So we will have hydraulic turbine, steam turbine, gas turbines, wind turbines. So different types of turbines are there. In pump aspect, we already discussed, there will be like human heart also on pump I told, and there will be centrifugal pump, axial pump. So different types of pumps are there. Okay, so now you know the definition difference between pump and turbine. Now another definition is the fluid machine. So fluid machine, actually the fluid machine will be dealing with fluids. So that fluid can be turbo machine, pump, or fluid flow through pipe or nozzle or jet, anything that will be coming under fluid machine. So anyone is talking about fluid machinery, so they will be talking in general of fluid machinery, like say piping, pumping systems, turbine, compressors, axial fan, everything. So in marine engine system, we will be discussing lots of thing about fluid machinery. Okay, fluid machinery, energy. So energy and fluid interaction we will discuss, and everything is coming from thermodynamics. Now thermodynamics second law you cannot violate. So whenever you are designing any machinery or you are buying any machinery, you have to check whether it is violating it is following thermodynamics second law or not. Okay, second law will say some losses will be there, and how much losses you are having. If you are having too high losses in some machinery machine element, then maybe fuel consumption will be very high. Again, if some company is claiming, let's say, efficiency 100%, again you have to suspect whether they are following the second law of thermodynamics, because there must be certain amount of losses. So that losses must be counted when you are talking about efficiency performance. Again, during discussion of pump, we discussed about centrifugal and axial. Centrifugal, axial, and other type of fluid machinery you consider, such as there is piston pump, diaphragm pump, many type of pumps we considered. So here turbine also will have centrifugal, axial type, but piston type and other type pump, those will not come under turbine. So those will be coming under maybe a hydraulic engine pump or something else. Okay, so turbine will be normally centrifugal, axial, and they will have again a reaction turbine and impulse turbine. Okay, so there will be different types of axial or centrifugal turbine there, and they will have reaction turbine or impulse turbine or mixed of reaction and impulse turbine. And whenever talking about pump will be including compressor also. So pump will be including compressor, because compressor takes energy and it will be compressing air. So you are giving energy to fluid. Compressor. Okay. And turbine can be run using your gas. In gas turbine system, gas can be your working fluid. We say working fluid means that fluid you are giving, that fluid will be carrying lots of energy, that energy will be given to turbine. Okay, gas turbine, steam turbine, a hydro turbine. Hydro turbine means like river water turbine, you are giving tidal power turbine. So those are hydro turbine. Hydro means water, so water turbine. So it can be run by gas, steam or hydro or water, or any other liquid also possible. For example, ammonia also can be your working fluid. So turbomachinery blade nomenclature. Okay, so first we will see the turbomachinery definition. So turbomachinery defines the transfers energy between rotor and a fluid, and typically gas or liquid, okay, or steam. Gas may be steam, you can say, gas or liquid, or gaseous phase and liquid phase. Turbine extracts energy from a fluid flow and converts into mechanical work. So here one example I have given from my research work. Actually, this is actually tidal turbine. Tidal turbine blades. So same as wind turbine. So instead of wind, water, ocean water will be driving or rotating this turbine blade. And when it is rotating, actually it generates torque. So torque will be producing power. Torque into omega equals power. Torque into omega equals power. Torque and omega means rotational speed of turbine. The turbine, and power in, let's say, torque in Newton meter, omega in radian, then power will be in Newton watt. And turbomachinery blade nomenclature. So turbomachinery blade will be looking like this. So it will have one airfoil. Okay. So here I have one turbomachinery, is not exact turbomachinery, but someone has designed and gave me like is similar to turbomachinery, you can say. So if fluid is flowing through this gap, okay, so what will happen? Fluid will be pushing these blades, it will transfer momentum or energy, and it will be rotating continuously. Okay, continuously it will be rotating if fluid is flowing from this side. If fluid is coming from this side, then fluid will be hitting this surface. When hitting its surface, momentum will be transferred or energy will be transferred, and blade will be trying to rotate in this direction. Okay, so when fluid is flowing through the blade passage, these are called passage. Two blades are there. So I have one blade, I have another blade. This is called blade. Okay, so these are called blades. So blade can be curved or different shapes will be there. Okay, and in between the space is called passage. Okay, and if I say top view, this one and this one, to this one and this one I am drawing here. You can see this drawing. Okay, so these are called blades, and in between the space is called passage. Okay, fluid will be passing through the passage. It cannot pass through the blade because solid body. Okay, the vacant space is there. Through this one, blade fluid will be flowing. Fluid may be gas, steam, water, anything, or aniline or petrol, diesel, anything can be possible. So it will be passing through this one and it will be rotating. Okay, so okay, now blade, this shape, these are blades, and blade will have different shapes. Okay, some blade shape will be this top section. If I see, this one is like looking like this. This most probably hydro airfoil, hydrofoil. I cannot say hydro airfoil. This is hydrofoil. In airfoil, normally it will be shaped like this. One section will be thicker, one section will be thinner. This is called leading edge. This is called trailing edge. This portion leading edge, this is called trailing edge. Trailing edge. And if this is bent like this, okay, this upper surface, this surface is called suction surface, and this surface is called pressure surface. So whenever you are discussing or writing, whenever you are discussing about turbine, so you should remember the names leading edge, trailing edge, and the top portion is called turbine tip. So if I assume this is my blade and whole blade is drawn here, this 3D you can see here I have drawn, okay, and I have cut from the hub, this is called hub section, okay, this is called hub. You see wind turbine hub, this is blade, okay, and this is leading edge, this is trailing edge, okay, and this is called tip, okay. uh, so in a turbine blade I have blade tip, I have leading edge, I have trailing edge, okay, I have suction surface, I have pressure surface, okay. These basic things you have to remember whenever you are analyzing turbine, okay. Now turbine, this shape can be very thin or maybe purely airfoil shape, okay. In many cases turbine blade shape can be like this, like crescent shape, okay. Some cases it can be like airfoil shape. So presently I have drawn this one airfoil shape turbine blade, okay. So fluid from, like say if I assume on airfoil, okay, so in a turbine blade, so fluid will be moving from leading edge to trailing edge, okay. So I have airfoil section. So if I see this 3-dimensional blade, it will be lots of airfoil sections are there in this blade actually, okay. Like one section, second section, third section, fourth section, and if I connect all this line, it will be creating one blade, okay. If you know CAD modeling, so normally we draw airfoil shape to 1, 2, 3, 4, then we loft, we connect all the airfoils and it becomes blade, okay. So airfoil leading edge there, and fluid will be flowing over it, leading edge to trailing edge, okay. It is like this. So this is flow direction. So when fluid is flowing over the blade, so blade will get lift and drag. Lift is perpendicular, lift force. So we say lift force or lift only, and perpendicular to flow. Perpendicular to flow direction, and drag parallel to flow direction, parallel to flow okay. So whenever fluid is flowing through airfoil over airfoil shape, so airfoil will get lift and drag. Drag means fluid will try to drag along its path, drag the airfoil along its path. Over lift means because of this cambered shape, fluid will be pushing this airfoil towards one direction, perpendicular to its flow direction. So this is called lift or lift force, okay. So whenever you are designing or you are looking at any airfoil, you have to see what is the lift and drag or lift and drag ratio. This will be deciding whether your airfoil is very good, properly designed or not.